Hey everybody, Jim here, and today we're going to be doing a review of this Kenuos 7500 watt tankless water heater. It's very pretty, and it comes with the pigtail, and I've already been inside of it, but I'm going to take it apart again to show you a few things that are in it. So let's get started. Before I can show you what's inside and how this works, I have to connect up a 40 amp circuit to my test vents. Let's get started on that. Before I start on the montage of me hotting up the electrical, let me first tease this open and we'll have a peek inside. It's just two screws on this side. And it folds up with a little snap sound. That's reassuring. And then you see the insides. So I'm going to figure out what these two components are. I really want to think that they're MOSFETs, but it could be that they're just silly old relays. There's no telling. Well, that's nice and toasty. I'm recording this after I did so much of what you're about to see, and that's why this is toasty. Here on this side, let me get you a nice macro view. This is high temperature silicone in between the spot where the heating coils go into the kettle. And you have this fun rectangular kettle. I don't know what it looks like on the inside, but I imagine that it's just passing the water over each of these, what I'm guessing are 3 different heating coils. And it starts down here where you have an ABS connector with a copper sleeve on it, or brass, forgive me, which goes up through a, well, looks like a steel pipe, or copper, or I don't know what that is. That could be brass. That could be any number of things. I don't know what this is made of, but it feels like aluminum, to be honest, and it looks like aluminum. And then there's a sensor here. Let me find out what these two components are. The electrical bits look pretty clean. I don't see any issues there. And then you have another ABS connector with another brass sleeve coming out at the hot side. Let's find out what these are. Well, I have decided to reshoot this part of the video. Here on my front porch, I've got good natural sunlight. Yeah, that looks pretty good. Okay, so this keying device has got some ABS connectors with the brass sleeve, and then the flow meter there, and then a temperature sensor, and then it comes here to a BTA60-800B triac that's mounted right onto the pipe coming in from the cold water supply into the kettle. Sorry about the mailman across the street. And then it comes into this keen aluminum kettle. It's really pretty. I'm very impressed. I just don't I can't explain how it's made, but it looks like a solid piece of cast aluminum with the 3 heating coils inside of it. It's got this KDS 307 automatic shut-off switch, this thermostat that automatically shuts off at 95 degrees. And then it's got a pair of relays in here. And these are rated at 30 amps, but they're wired in parallel so that they go to these 2 red wires, which then combine to go to the other leg of the heating coils. So the triac controls this end and the relays control this end. My thought is, because I don't hear clicking when the thing is in operation, that these are just always closed. These are normal open relays, and I checked with the multimeter, and sure enough, they're open. But I never hear clicking, so they must be either really quiet or they're just really quiet. That's about it for the inside of this. Real simple stuff. I'm very excited that it's got a triac controlling this, and then the heat that's generated by the triac is transferred into the cold supply line before it enters the kettle. So you get a little boost of efficiency when you operate this. Yep.
Just look around, walk around and see. Working down in misery.
Alright, this is looking pretty good. I've got my sub panel out here in the shed, and it has 6 spots for breakers, and in the top right I put this double 40, and double 40 is going to go great with your 8 gauge wire, and it's tied in there real tight. And my ground wire comes out right in here. I shouldn't be pointing to it with a screwdriver, but it comes out here and then goes into this ground bar, which is not to be confused with the neutral bar. So when you have a sub panel, you don't tie the neutral and ground together. Those have to be tied together in the main breaker panel. But out here, I just have a ground. These tankless water heaters, they don't have a neutral line. They just have 2 hots. They're very European or Asian. So let's move on to the next step. Notice that, again, this is 40 amps and that it's turned off for safety. So here I've got a 60 amp quick disconnect that is typically used for something like a hot tub, but in this case we're using it for our tankless water heater, which by code needs to have a quick shut off. Now technically by code, because from the water heater I can see the circuit panel, I don't really need this, but it's very convenient and I like to use it anyway, so that's what I'm going to do. I'm going to install this, and this is going to be the quick disconnect. So it's set to off now, and I'm going to put in my 3/4 inch stress relief grommet right here. I want to get this as straight as I can, because my concern is that the screws will actually go back and hit the wood, which probably isn't a problem since I'm mounting this up here off to the side, right about like, oh, probably about there. And so, yeah, those screws won't hit any wood. It'll be fine. Well, there's the final finished product. That quick disconnect is ready for use, and I don't know how I lucked out, but I guessed how long the line was. Normally I would measure this, and I calculated it based upon the number of 2x4s on 18-inch centers, but boy, I thought I had an extra 6 inches or so, but I had just enough to get to that box. So there's my 8-gauge wire. It's I think it's a 10-foot run, and not a bad deal. So I've tightened it down real tight. In this particular box, you can actually, well, maybe you can't see it, but just there it says the word line, and on this side it says line, and here on this side it says load and load. So it wants you to put the load on the middle. Don't worry, it's off at the circuit breaker and off in here, so I'm not shocking myself. The ground wire goes right in here. This is just regular old 8-2 wire, not 8-3. There's no need to buy 8-3 wire with these tankless water heaters. You just need the 8-2. But that's it. So you got your again your hots on the outside, your ground going to this particular block right here, which is itself connected to this box. And yeah, we're about to do some reviews. Alright, my test system is nearly complete. I've got a little faucet mounted here on the lip of this shelf, and when the water comes out it'll just go into the wash machine, which isn't a big deal. And then I still need to put my tankless water heater right up here, and I think this is a good spot, just about right there. Let's do that next. Okay, now it seems like it's ready. So I got the power connected, and yes, I didn't run it through the hole at the bottom along with a stress relief grommet. But don't worry too much. I'm just setting up this way so that we can do some testing electrically to find out how many watts the thing is actually drawing when it is generating hot water. So I put a splitter in there in between the hot outlet of the tank. Oh, well, let's see, where is it going? Did I do that? I actually... Cold's on the right. I'll be darned. I actually hooked this up backwards. Well, hold on a second. That's more like it. And it's much neater now. So my cold comes out, loops up behind the thing, comes down and goes into the right-hand side where the cold typically goes. And then on the hot, I've got a brass splitter that goes off to the spun faucet right here, and loops around, goes out of sight just here, loops up, and then goes into the tankless water heater. So now I think we can charge it up and start the testing. I'm going to start by draining all of the air out of the system. Let me open up my wash machine first. There we go. Move this soap out of the way. Yeah, this looks pretty good. So let's start here. Yep. All right. Now it's draining right into the wash machine. Kinda. It's splashing a little bit, but I'll be okay. Let me move this over to the middle because I'm not going to close the lid during the test. Alright, great. We are ready to test. I've got a bit of a leak right here because this old braided hose, the washer in it has worn out. So I'm not too worried about that. Right now I'm just running water through the system to make sure there's no air and to get a good feel of how cold the water is when it comes out of the ground. 70.7. Alright, let's turn it on and find out what happens. Oh, that's awfully pretty. Alright, looks like I need to turn it on to get it to work. And it says that it's at 21 degrees Celsius. The hot water temperature, oh, that's cute. So it tells you the inlet water temperature, the hot water temperature, and the water, it actually shows you the liters, I'm guessing per minute. That's pretty slick. Okay, so maybe that'll save us a little bit of effort. Let's find out what happens. Oh, it's warming up pretty quickly. Ouch. 50 degrees. Ouch. Wow, that is really hot. I couldn't figure out what was going on. Why my loop meter wouldn't measure how many amps are being pulled by the thing. So I swapped it out with another loop meter. I don't know what the problem is with this one. This one says it's drawing 30 amps when it's connected to nothing. I'll turn this off. Let's see if we can push up the 22 amps that's shown there. Oh, that's nice. Alright, so we're at 21, 22 amps. I'm going to pump up the volume. Okay, so it's jumped up to 32 amps. Now 7,500 watts should be approximately 34 amps. Right now it's drawing 32 amps. 36 amps. Let's see how high it'll go. Alright, so the system stops at 36 amps. That's a hair more than 7,500 watts at 220 volts. But I'm not going to complain because I have a 40 amp circuit. I'm very pleased. Normally, when you're running one of these Celsius devices, you want to go for about, I think it was 45. Get you a nice hot shower without burning you up too badly. And it's definitely working. This is hot as can be. Let's see how hot this is. Alright, it says hot water temperature is 38. Alright, I'm going to aim the camera down so we can do our coffee cup measure. Let's see. Oh, there it goes. So right now it says 45, and I'm getting 45, 46, 46 and a half, 47. So it's a little warmer coming out of the faucet than is reported on the device. But this is a flow rate of 3.9 liters per minute, according to the machine. I think I'm ready to make a decision and say that this device is pretty awesome. If it's really running at 36 amps, and it sure looks like it does, and it feels like it, then it's going to add 36 degrees Fahrenheit to every gallon that passes through it at a rate of 1.5 gallons per minute. My demonstration was about 1 gallon per minute, and it added plenty of heat. It got up to 55 degrees Celsius, whatever that is in Fahrenheit. I'll post it here in a minute. But yeah, at 36 amps, 220 volts, that means this thing is on par in terms of heating with these silly EcoSmart 8s. Why is that a big deal? Well, this device costs you under $100, at least on today when I'm recording it in March of 2023. It cost you about $99.80 on the popular big box store, where everybody buys everything. Whereas the same level of heating with this EcoSmart 8 will cost you about $240 on all the websites. So yeah, it's a great bargain. I had it open about a week and a half ago for a problem that I wanted to diagnose, which was actually my own fault. The thing doesn't leak. It's actually quite nice. I'm testing it too. No moisture at all. All told, I'm really pleased. Just an inexpensive device. And if you want to go, if you live south of I-20, this device will probably work pretty good for you for sure. If you live south of I-10 here in America, if you live south of the 25th parallel, then yeah, you're probably going to be just fine with this device heating the water going to your shower and your wash machine and your sinks. So yeah, I'd definitely recommend this device. I like it a lot. It works just fine. Well, I sure learned a lot making this video, and I hope you did too. Thanks so much for watching.